Hi friends, hope you are doing well, and I am here with another interesting series of lessons. So in this series we are going to talk about page replacement algorithms, and there are many algorithms, but before moving to that step I want to discuss with you some important points, and that points will lead you to page replacement algorithms. So then you will easily understand what are these algorithms and what is their job. So the very first thing that I want you to tell is, and this point I know that everybody know this, for an execution of a process, that process has to be in the main memory. So that means if a process is not in the main memory, that process cannot be executed. Yes, so if I explain it more with this is process A. Let's take this as process A. So if this process A wants to get executed, it should be in the main memory for sure. And this main memory is also known as the physical memory. So if this process A wants to, no, let's say like this, if the CPU wants to execute process A, it should be loaded to the main memory. Otherwise, this process A cannot be executed. So this is the very first thing, the basic thing that I wanted to tell you. So now there comes a problem. That is, what will happen if the process is larger than the main memory? So let's take this process A. Here, this is process A, and this is the main memory. The size of the main memory is smaller than the process A. So what will happen now? Then we can come up with a solution like this. Rather than loading the entire process, we can load some parts. We can load some portions of the process to the main memory. Right? So let's take this part as A. Let's name it as A. So this part A, we can load this part A to the main memory. So these other parts, they remain in the secondary memory. Only this particular part A will be loaded to the main memory because only this part is required. So we are only loading the required part to the main memory. So in such a situation, there is an advantage. That is, in the main memory, there will be lots of processors at the same time. When we load only the particular part, only the particular portion, it is a less amount of size. So in the main memory, that particular process takes a small space, right? So what happens? Many processes can be there in the main memory at the same time. Otherwise, if we load the complete process, this large process, it will take a large space in the main memory and only 1, 2 or 3 processes will be there in the main memory at the same time. So this is the advantage. I think you understood what I said, and now we have the answer for this question. But we are still not done. Then there comes another issue: how to implement this, how to implement what I said before. So this is how we do it. We are going to divide the process into equal sized portions. Equal sized. Each and every part has an equal size. So this is process A. One of these parts is called a page, right? When a process is divided into equal sized portions, one portion is called a page. So now what happens is, if the CPU needs a particular page, only that page will be loaded to the main memory, right? So let's take this page. So here the pages are 0, 1, 2, 3 and 4. That means this process has 5 pages. We start from 0. So let's take this page 3 is required by the CPU. So what happens is, only this page 3 will be loaded to the main memory, and the other pages 0, 1, 2 and 4, they remain in the secondary memory, right? So this situation, this kind of a situation, it is also called as demand paging. Demand paging. So I'll tell again what happens. We divide a process into equal size portions, and only the particular portion which is required by the CPU will be loaded to the main memory when others remain in the secondary memory, and this is called demand paging. So now we have the answer for this as well. But still this questions are not over, and again we get a problem, and that is, what will happen if the required page is not in the main memory? So let's take that there's a page called 1. So this page 1, this page 1 is required by the CPU. This is process A. But this page 1, it is not in the main memory, right? So this is called a page fault. This is called a page fault. So what is a page fault? A page fault is if a required page is not in the main memory, then it is called a page fault, right? So when a when a page which is required by the CPU to execute is not in the main memory, it is a page fault. So what happens when a page fault occurs? Then what happens is, when the operating system, when the OS gets to know that the particular page is not in the main memory, then the OS will find the particular page in the particular process, and the OS will load this page to the main memory. So what happens? I repeat the same thing. When the OS gets to know that the particular page is not in the main memory, what it does is, it will find the particular page in the particular process and it will load the page to the main memory from the secondary memory. So that is what happens when the required page is not in the main memory. And also this is called a page fault. So now we have the answer for this as well. But still the problems are not finished, and we have a problem again, and that is, what will happen if the main memory is full? What will happen if the main memory is full? So let's see how to solve this. I told you before that a process can be divided into equal sized portions. And one is called page. Right? As same as a process, the main memory is also can be divided into equal size parts, equal size portions. And in the main memory, one part is called a frame. In a process, it is a page, and in the main memory, it is a frame. So the meaning of this main memory is full means, that means each frame is having some processes, right? So if each frame is having processes, that means the main memory is full. So then what will happen? So let's think that we want this page 2 to be loaded to the main memory, but because of these frames are full with processes, this page 2 cannot be loaded. So in such a situation, what happens is, there are pages in this frame, so some page will be swept out. I'll explain that word later. So some page will be swept out to the secondary memory, and the particular page which is required by the CPU, here it is page 2, this page will be swept into the main memory. Swept in. Some page will be swept out from the main memory to the secondary memory, and the particular page will be swept into the main memory from the secondary memory. So when a page is moved from the main memory to the secondary memory, it is called swept out. And when a page is moved from the secondary memory to the main memory, it is swept in. So this will happen when the main memory is full. We have the answer now. Now I'm gonna ask you the very last question. I'm not gonna ask any questions again, and that is, which page will be swept out? Now I told you that some page will be swapped out and the particular page will be swapped in. So from these pages in the main memory, which page will be swapped out? And that will be decided by page replacement algorithms. So finally we heard the word, our topic, page replacement algorithm. So they will decide which page will be swapped out. So finally I finished the all steps and I think you understood what are the page replacement algorithms and what is their job. So to tell that, I mentioned lots of important facts and I hope you understood what I said so long. So finally we are done with the introduction. Right, so at the very beginning I told you that there are a number of page replacement algorithms, and in the next videos I'm gonna discuss them with you. So there are three main algorithms that I'm gonna discuss with you, and they are least recently used page replacement algorithm, and then first in first out page replacement algorithm, and finally the optimal page replacement algorithm. So I'm going to discuss these three page replacement algorithms in a separate video. So the links for those videos, they will be given in the description. Right, then let's meet with a new video. Thank you.